The stress-strain diagram shown is the result of a tensile test performed on a ductile material. What point corresponds to the yield strength? So in materials, things are a little less quantitative, so you're more likely to get questions like this where you just have to understand something, some concept. In this case, it's about the tensile test, which is a really common test of any material where they basically stretch. So you take a member and you stretch it out and you see what happens. And what happens initially is that it deforms elastically, and that really happens in this linear range. So we call that the elastic region. And when you take the force away, when you stop stretching it, it goes back to the way it was if you're in that range. So that's the elastic region. And when we use the table typical material properties and we look up the Young's modulus, the modulus of elasticity E, or the modulus of rigidity G, those quantities are applicable in the elastic region. The yield strength corresponds to the point here, point D. That's the best answer, is B, beyond which the deformation that's experienced by the member is no longer elastic. When the force is removed, it's not going to restore. It's not elastic deformation anymore. It's plastic deformation, and it's going to be permanently deformed. And that happens to various degrees, and depending on the material, whether it's a ductile material, there's going to be a kind of a different shape and characteristic of where points D, E, F, and G are related to one another. But each type of material has a different slope going from A to C, and that's an important design parameter because generally speaking, we want to use materials in this range, and we don't spend too much time examining what happens from D and E and onward because we generally don't want to go there. So most of our studies focused on the elastic region, but it is important to know where the yield strength is, D, and F is the ultimate strength, so that's another good one to know.